axiomatic approach to probability. Let S be a sample space containing the outcomes omega 1, omega 2, etc. omega n. That is S equal to sample space S equal to set to omega 1, omega 2, etc. omega n. Then from the axiomatic definition of probability, so that axiomatic approach probability says that these three conditions, that means 0 less than or equal to probability of omega I less than or equal to 1 for each omega I belonging to S, sample space S. That we have studied probability of all outcomes, that is between 0 and 1, including 0 and 1, that we have already studied. Then P of omega 1, probability of omega 1 plus probability of omega 2 plus etc. probability of omega n equal to 1. So I will show you one example. Consider the experiment of throwing a die. Consider the experiment of throwing a die. So the sample space is set S equal to 1, 2, 3, 4, 5, 6. That is sample space for that experiment. Now we know what is the omega 1, omega 2, etc. omega n. That means elements of the sample space, omega 1. These are the elements of the sample space or possible outcomes. Now here, what is the probability of occurring 1, probability of getting 1? When you throw a die, what is the probability of getting 1? Probability of getting 1, that is equal to 1 by 6. And what is the probability of getting 2? That is also 1 by 6. And probability of getting 3, 1 by 6. And therefore, what is the probability of omega 1 plus probability of omega 2 plus etc. probability of omega n? That means probability of getting 1, 1 by 6. So probability of each outcome equal to 1 by 6. So there are 6 outcomes. So when we add all the probability, what we get? 1 by 6 plus 1 by 6 plus. So probability of getting 1, 1 by 6. Probability of getting 2, 1 by 6. Like that, probability of occurring 3, 4, 5, 6, all equal to 1 by 6. So we have to add 1 by 6, 6 times. So that is when we add the sum of the, when we add the probability of all the outcomes, we get 1. So here, when we add the probability, we get 6 by 6. That is equal to 1. So sum of the probability is equal to 1. So that is the second one. Then third, for any event A, probability of A equal to sigma probability of omega I, where omega I belongs to A. That is, consider any event. So in the same experiment, consider the event E equal to or A equal to, consider the event A equal to getting odd number. In the case of this experiment, probability of getting odd number. Which are the odd numbers? 1, 3, 5. So consider the event A getting odd number. That is 1, 3, 5. A equal to 1, 3, 5. So here it says that P of A, probability of A equal to sigma probability of omega I, where omega I belong to A. So here elements of A. So probability of A, here probability of A is equal to probability of the event A, that is equal to sum of the probabilities of elements of A. That means probability of getting 1. So that is equal to probability of getting 1 plus probability of getting 3 plus probability of getting 5. That is probability of getting 1, that is 1 by 6. So 1 by 6 plus probability of getting 3, that is 1 by 6. Probability of getting 5, 1 by 6, that is equal to 3 by 6. So probability of A equal to sigma probability of omega I, where omega I belong to A. So that this third condition says. So we get probability of A equal to 3 by 6, that is same, that is equal to 1 by 2. So that is what third condition. So these are the conditions of axiomatic approach to probability. Axiomatic approach to probability. So when S is the sample space, then probability of each element will be between 0 and 1, including 0 and 1. Then sum of the probabilities of all the elements, that will be equal to 1. Then for if you consider any event A associated with that experiment, probability of any event A equal to sigma probability of omega I, where omega I belonging to A. So if you find the probability of each element of A and add, you will get probability of A. So that is what this example says. So that is what axiomatic definition of probability. Now next you have to remember the term equally likely. What do you mean by equally likely outcomes? See here, suppose S equal to, sample space equal to omega 1, omega 2, etc. omega n. So if all the outcomes are equally likely to occur, equally likely to occur means they have equal chance of occurring. each element of the sample space has equal chance of occurring. So if the outcomes are equally likely, probability omega 1, probability for the first element equal to probability omega 2 equal to etc. probability omega n. That is probability of the occurrence of each element. They are equal. Probability of omega 1 equal to probability of omega 2 etc. equal to probability of omega n. So that is the meaning of equally likely. Outcomes are equally likely to occur means they have equal chance of occurring. Probability of each element is same. Now next point, in that case, if the all elements of the sample space, all outcomes of sample space are equally likely, then we can find the probability of an event E using this formula. Probability of E, event E equal to number of E by number of S. That means number of outcomes favorable to the event E divided by total number of outcomes in the sample space. That also we have studied in 10th standard. So when all outcomes are equally likely, then probability of any event E associated with that experiment equal to number of E by number of S. Number of elements in E by number of elements in S. We know E and S. Any event is a subset of sample space and it is a set. So number of E means number of elements in the set E divided by number of elements in the sample space. So that is the formula, very important formula to find probability of an event E. Number of E by number of S. Next point, probability of A union B. If A and B are any two events associated with an experiment, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So A union B, that is same as A or B. So probability of A or B equal to probability of A plus probability of B minus probability of A intersection B. So next point, probability of not A. So we have seen not A is an event that is called A complementary event. So probability of not A is equal to probability of A dash, that is complementary event, equal to 1 minus probability of A. That also we have studied in 10th standard. Now we will prove this probability of A union B. This is very important formula, very important. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So probability of A union B is same as probability of A or B. So we will prove that property. Consider the Venn diagram. So here this is A, this is B, and we know this path is called A minus B, and this path is called A intersection B, and this path is called B minus A. So A minus B means elements in A but not in B. That means from A common to B is removed. So this path is called A minus B, elements in A but not in B. So similarly this path is called B minus A, elements in B but not in A, B minus A. And this is the common path, A intersection B. That we know, that Venn diagram. Now here we can write probability of A union B. Probability of A union B equal to probability of A plus probability of B minus A. See here, this is A and this is B minus A. So these are disjoint sets. Therefore we can write probability of A plus probability of B minus A, this part. So they together form A union B. A union B means A and B all together. So this probability of A union B is equal to probability of A plus probability of B minus A. Now we know what is probability of B. Probability of B equal to, we know B is the union of what? B is the union of A intersection B. This is the common part. A intersection B and B minus A. So probability of B, this B whole, is same as probability of this A intersection B, common part, plus probability of B minus A. So that is equal to probability of A intersection B plus probability of B minus A. Now from this equation, we get probability of B minus A. Take the probability of A intersection B this side. So we get probability of B minus probability of A intersection B equal to probability of B minus A. So we can substitute in the place of probability of B minus A, we can write probability of B minus probability of A intersection B. So this we can substitute. So this, suppose it is 1, this is 2. So substitute this in equation 1. So what we get? So from 1 and 2 we get, from 1 and 2 we get probability of A union B equal to, here this is probability of A plus, then probability of B minus A. This part, this is same as probability of B minus probability of A intersection B. So this value of, we can substitute in the place of probability of B minus A. So probability of B minus probability of A intersection B. So we got that formula. That is probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So you have to study only this formula. Standard formula, very important formula. Probability of A union B. If A and B are any two events, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Now, one more condition we have to remember. That is, in this formula, so for any two events, very important formula this one, probability of, for any two events, probability of, if A and B are any two events. So if A and B are any two events, you can apply this formula. Probability A union B equal to probability of A plus probability of B minus probability of A intersection B. So that is very important formula. Then from that we will consider one case. That means if A intersection B equal to null set, what happened? If A intersection B equal to null set, that means then in that case A and B are called mutually exclusive. That is, A and B are mutually exclusive. A and B are mutually exclusive. So in this formula, if A and B are mutually exclusive, that means A intersection B null set, then what happened to this formula? So in this formula, if A intersection B equal to null set, that is, what is the probability of A intersection B? If A intersection B equal to null set, what is probability of A intersection B? Probability of null set, impossible event, 0. So probability of A, in this case, if A and B are disjoint, A intersection B null set, that means they are mutually exclusive, then probability of A intersection B is 0. So when we apply this value in the formula, probability of A intersection B becomes 0. So what is this formula? Then what happened? Then probability of A union B equal to probability of A plus probability of B. So that is very important formula. So this is this formula we can use when A and B are mutually exclusive. So only if A and B are mutually exclusive, you can write probability of A union B equal to probability of A plus probability of B. So mutually exclusive means very important term. That means A intersection B equal to null set. So if A intersection B equal to null set, A and B are called mutually exclusive events. So if A and B are mutually exclusive events, probability of A intersection B is 0. Then probability of A union B equal to probability of A plus probability of B. So study these two formula, this formula and this formula. This is for any two events A and B. For any two events A and B, you can use this formula. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. If A and B are mutually exclusive, you can use this formula. Probability of A union B equal to P of A plus P of B. Okay.